Kalau ngomong kayak gini terus nggak apa? Apa? Tiga tuh ngomong. Chat. Good afternoon, everyone. Welcome to Pycon APAC 2024 third session. My name is Sonia Bakis, and I will be your moderator for this session. It's my pleasure to introduce our speaker for today, who will be presenting on database replication with Django and Postgres. Please join me in welcoming Mr. Martin.
Okay, hello everyone. Welcome to my presentation, Database Replication with Django and Postgres. My name is Marcin. I'm a principal developer at Sailor Commerce, which is a startup, and we are building e-commerce platform. You can think about it as an alternative to Shopify, but this platform is open source. It's built in Python and Django and a GraphQL API on top. It's based in Poland, and I came all the way from Poland to attend Pycon Indonesia, which I'm really happy about. It's my first time in Yogyakarta, and I really love it. If you are curious about this project, you can check it on GitHub.
Thank you.
So let's talk about database replication. Let's start with some theory first. So database replication, as the name suggests, is a concept of storing the same data in multiple databases. So usually when you start building a project or you have a small project, you most of the time have one database, one instance of a web server, and that's it. That's usually enough at the beginning. But when your app grows bigger and you are serving really heavy traffic, then at some point you need to start thinking about introducing replica databases, as on this schema, to have more copies of your data in order to make your platform faster, basically, to respond to your users. So database replication is about having the same data on multiple databases. And by the way, this model is leader-follower model, where the primary database is the one that we use for writing data, and the replicas are basically following all the changes from the writer database. Why do we need database replication at all? So let's have a look at this chart. This blue color over here is read requests from our API. So this is basically a chart from our platform. And over one day, we serve around 2 million of requests. And as you can see on this chart, almost 2 million are read operations and only 100,000 are write operations. So it's true for e-commerce sites. Actually, this is true for any other applications, if you think about it. Most of the time when we are browsing data or using our apps on mobile apps, we are most of the time rather fetching data and reading stuff. Yeah, when we are scrolling, writing something, buying stuff online, most of the time we are just reading. So in order to serve this huge amount of traffic that is only read operations, we are using database replication in order to optimize for this type of traffic. The benefits of database replication. First, scalability. Because we have more databases, we can distribute loads into multiple database instances, which offloads traffic from our single writer so that it can perform faster. Then, availability. So, in case, if you have a large production with complex architecture, then it's really likely that something fails. For example, your database server fails at some point. Your main database server can fail because of network issues, disk issues, or many things can go wrong. So with database replication, you can easily replace your main database with one of the replicas. And last benefit would be the latency. So if we are hosting our application in, for example, AWS or Google Cloud or some other hosting providers, we could keep those replica databases in different parts of the world, basically. So if the app is serving global traffic, then we could have application in basically different availability zones and put the data closer to the users, actually. Let's look at some of the basic replication types that are available in Postgres. But actually, these are also implemented in other database servers as well. So we have two types. Logical replication works on a table and row level in the database. So if you have your writer DB, your main DB where you write data, whenever an SQL query comes in that writes something, logical replication will send this query into all the replicas in order for them to make the same write, basically. Postgres is using some internal data structure to transport this information to replicas. And logical replication works like pub/sub model, where the primary DB is a publisher and replica databases are subscribers. And in order to create that, you can use those SQL statements, basically. This you would run on your primary database to create a publication, and this you would run on the database that you want to follow, the main database. Basically, this will subscribe to changes from this one. So this is logical replication. And the second one is physical replication. So in this case, it's more on a byte level. So if you read about how database stores data on disk, data is stored in blocks, basically. It's called also pages. These are 16 megabytes, if I'm correct, 16 megabyte size of blocks. And in this case, instead of sending one by one SQL statements, we are transferring entire disk blocks into different database servers. So this is a little bit more low level. It's used for different use cases. Yeah, and also one of the type of physical replication is also shared disk, the file system. So this one, for example, is used, if I'm correct, by AWS Aurora. This is Postgres, like based on Postgres version that AWS is providing in their cloud. And Aurora supports replication, and these replicas are basically sharing the same disk space. So there is no need to transport pieces of your data over the network. It's basically sharing the same disk space. So this is some theory about database replication. Last one topic is replication lag. It's one, unfortunately, it's not very clear with those colors, but which shows value from our monitoring from our platform, value of replication lag. What is replication lag? As I said, when data needs to be transported from primary DB to our replicas, it can be done either over network or by disk operations. So those operations take some time, yeah? So it's not instant. Usually it's fast. Usually you wouldn't notice any lag, but under heavy traffic, if there are many requests coming to your writer DB, and it needs to copy this all data to replicas, the replication time may grow, basically. So usually the values over here are around like 10 milliseconds to 60 milliseconds. That's normal. But under heavy load, when you are, for example, expecting, I don't know, a big sale in your e-commerce website and thousands of users are, then this could go to, I don't know, a few hundred milliseconds or even seconds. So then it becomes visible, and if you're fetching data from your users might get outdated information, basically, for this amount of time. So it's a very short amount of time, but in some situations, you have to be careful about this. And we're gonna see one example when you have to take that. So this was the first part about the theory, and now I'll show you some practical examples how to use database replication with Django, as Django is the main framework that I know. So yeah, we will start with settings.py. If you ever use Django, this is the main configuration file where you define all kinds of configuration, and database configuration is one of the basic ones. So usually you would have only this part. Default database, that's the one that we use at the beginning. But in Django, you can add more databases just by adding more entries into this dictionary. So in my simple example, I'm using two databases. One default database is the primary one. This is used to write data. And this one is the replica, which will follow the first one. So I'll skip the part where we configure it in Postgres because we don't have that much time. But assuming that we have this already configured, that would be our settings py. Next, in order to use that in your code, you have a few different options. And the first one, the basic one, would be to add DB router. This is a simple class that you write, and you add that in your settings py as well. And we can implement a few methods in this class. These two are, let's say, the most basic: DB for read and DB for write. So when you add these methods, you can say which database connection should be used for read and which should be used for write. And assuming that we have some product model, we are fetching the product by name and getting the first product. When Django sees this kind of query and you have this DB router configured, it will see that this is a select query, it's a read one. It will use this method, this database connection. In other case, when you are saving data, so I'm changing the category of the product and I'm saving it with Django ORM, this will actually run the update SQL command in my database, and Django, when executing this, it would pick this database connection. So that could be like entire configuration, and all your reads would go through replica. From it's not always the case. In some situations, we need to control manually which database we want to use. Sorry, I need to check my timer. Yeah. So, for example, consider that we have endpoint or a view in our application that returns a product page in our web shop or something like this. So we have this simple function, get product. It gets the product from database, returns some template response. This could be JSON response or HTML up to our application. So this is the, on the chart that I showed earlier, the blue part, the big one. So this is most of the traffic that, for example, our application gets. Basically reading data. So in this case, we can always pass the using function, which tells the ORM to use the replica DB for this kind of operations. So if you look at your API requests and you want to optimize them for using replicas for reading, you would just add this bit using and pass the name of the database connection. But in some other cases, for example, if you have a checkout, imagine that you are running if you are going to a online store, you have products in your cart, you finalize the checkout, make payments, then you click or finalize checkout, something like that. And then this checkout is turned into an order that shop administrators will see and process and deliver to you. So in this case, when we are going to implement this kind of view, we need to first get the checkout from database, do some operations with it, and create an order. In this case, we need to take into account the replication lag, which I told you about before. So we need to make sure that data that we are getting from database here is the most recent one. So we cannot allow this object to be even few milliseconds old or second old or under really heavy load, even more. So what we do is in cases like this, that we need to handle this crucial business logic to our application, we will always be using the default database in this case. In this example, a good practice is also to use transaction, and select for update in Django will lock this checkout object, this row in database, so that no one else changes that at the same time, basically. So this is to avoid this kind of edge cases. Yeah. So this was like all I've got about database replication. Lastly, if you need to make sure that your apps are performant, you could consider adding connection pooling to your applications, like PG Bouncer for Postgres, because connections are maybe not expensive, but they take resources. Each new connection from your server to database will use some memory, some time to establish the connection. So PG Bouncer would help you with having a pool of ready connections before. And the other thing that's really important is to monitor performance of your database queries. And very good tool that Postgres provides is the explain query. With explain, you can take your SQL query that's slow for some reasons and you don't know why. There are tools to visualize queries, and based on that, you can see what Postgres actually did underneath. For example, how long it took to use the index, and so on and so on. And based on that, you can optimize your queries to make them faster. Yeah, few resources for you that I use during working on this presentation, and I use quite often at my work. This book, I recommend designing data-intensive applications where all of those concepts. Also, presentation, if you are curious how the presentation works, the chart, basically this one, it produces, helps you to visualize how complex your SQL query is. PGCLI is really nice tool to interacting with Postgres locally. And that's all I prepared for you. You can scan this code to have access to slides. I don't know if we have time for questions. I think no. So you can find me if you have any questions, and feel free to talk to me. So thank you so much.
Ini udah selesai. Thank you so much, Mr. Masjin, for such an informative presentation. And have a great day, and please wait for another session after this. Ininya, suruh baca. Aku udah tak. Harusnya punyaku loh, punyaku. Mana? Ininya. Oh.